plate devices would not be feasible because of undesirable fluid characteristics or special design required. So Perry presented conditions favoring back columns, and these are the conditions. Number one, for columns less than 0.6 meters diameter, packings are usually cheaper than the plates kasi nga malawak yung plates, yung masyado mahal yun. Kaya, kung packings ang gagamitin natin, maliliit lang yun, and then, yun, mas cheaper siya. Lalo na, unless alloy metal packings are required. And then the next, acids and many other corrosive materials can be handled in pack columns kasi meron tayong mga packings na made of ceramic. Next, packings often exhibit desirable efficiency for pressure drop characteristics for critical vacuum installations. The liquids tending to foam may be handled more readily in pack columns. And then the holdup of liquid can be quite low in pack columns, which is an advantage to the liquid is thermally sensitive. Ito naman yung mga unfavorable kapag pack columns ang ginamit natin. If solids are present in the liquid or gas phase, thick columns can be designed to permit easier cleaning. Kasi kung sa pack columns tayo, marami tayong mga packings, mahirap ang cleaning. And then next, some packing materials are subject to easy breakage during insertion into the column. Pwedeng mabasag siya pag kakalagay pa lang sa iba ceramic. So yun. And then kapag may thermal expansion and contraction. Number 3, high liquid rates can often be handled more economically in plate columns than in pack columns. Tapos ito pa, cooling coils can be incorporated more readily into plate devices. Tulad nung pinakita kanina, yung mga may coils. The low liquid rates lead to incomplete wetting of column packings, thus decreasing contact. So flooding and pressure drop. Kailangan natin i-consider yung flooding and pressure drop sa pag-design ng ating pack columns. So in a given pack tower with a given type and size of packing, and with a definite flow of liquid, there is an upper limit to the rate of gas flow called the flooding velocity. Above these gas velocities, the tower cannot operate. Din-discuss lang dito kung paano nakaka-affect yung flooding natin. As the gas flow rate is increased at low gas velocities, the pressure drop is proportional to the flow rate to the 1.8 power. Since flooding or phase inversion normally represents the maximum capacity condition for a packed column, it is desirable to predict its value for new designs. Usually, pinapili natin yung pressure drop kasi madali siya i-relate sa flooding. So, maraming ways para ma-predict natin yung pressure drop. Pero ang pinakamadali ay paggamit ng generalized pressure drop correlation. So, ito yung itsura niya. Galing lang siya sa Perry. And then, yung parameters na nasa X and Y axis natin ay madali natin makakonfirm yung pressure. So, hindi na tayo masyado mag-dwell dyan. So, ito yung mga parameters na yun. Madali na siyang makuha in the pressure. Packing efficiency. Ayan. Sa packing efficiency, wala talaga tayong specific formula na nakakuha tayo ng definite value for the efficiency. Pero in pack columns, the efficiency is related to HETT of the tower. Ang HETT, ibig sabihin lang niya ay height equivalent to the theoretical plate. So the two-field model gives the following mass transfer unit relationship. HOG is equal to HG plus lambda HL. Kailangan natin itong equation na ito kasi nirelate natin siya later on sa HETT. HOG yung height ng overall transfer unit, HG para dun sa gas phase, and then HL dun sa liquid phase. And then the lambda, yung slope natin, kapag ginrap natin, yung diniscuss na rin ito dun sa gas abuan na group, lambda ay yung slope ng equilibrium line for the slope of the radius. Yan, packing efficiency. In design practice, unless rigorous parameter HATP is used. So yan, meron tayong equation kanina na HOG. Pwede natin siya i-combine sa equation dito para makuha natin itong formula na ito. Yung ZT, yan yung height ng ating tower. Kasi para makuha tayo ng height ng tower, yung total height ng ating tower, kasi pinag-multiply lang yung height ng overall transfer unit sa number. Yan. So, para makuha natin yung HL, kailangan mo natin mag-solve ng mga mass transfer coefficients. Kasi itong HL, in a lot of text, ano sila, expressed as a function of mass transfer coefficients. Pero medyo manahirap siya intindihin. Kaya nilamit lang tayo ng mga correlations. So, according to Gauss, nag-present Gauss on that ng correlations based on a large quantity of data. Pero yung mga natin values dito usually deviates from experimental data by up to 20%. The following correlation includes the following data. For certain types of packings, may mga measurements na kailangan para sa correlation. Ito na yung equation. Medyo mahaba siya, pero actually, ang kailangan lang dyan ay yung KL, yung mga K-values. Tapos yung mga parameters din dyan ay readily available din sa literature. Bali, kung isi-solve natin ito, ipa-plug in lang natin basta yung mga values na yun. Kasi, itong K at itong mga K na ito, dimensionless lang yan. Basta consistent kasi units mo, madali mo siya mag-solve. That's for the liquid phase, yun ang taas, and then for the gas phase. Ayan. Then the expression for the wetted surface of the packing, ito naman. Bali yung tatlong equation na pinpresent, yung for liquid phase, for gas phase, and then for the wetted surface, makakuha natin yung HG at HL. Ito yung mga ibig sabihin ng mga parameters doon. Pero nasa Faust lang siya. Medyo rigorous siya. And then ito mga to ay pag consistent yung sa ginamit ng units, makakancel din siya dun sa equation. Medyo, ano siya, madami, pero madali makuha. Yeah, sample problem lang. Calculate HL for the absorption of SO2 from air into water at 87 degrees Fahrenheit in 1 atmosphere for the given conditions. Yeah. So, gagawin lang natin, kung walang tayo ng literature values, yan. So, given ko mga values ito from literature, and then yung B, gumamit ng Gilliland equation, 1 for 9. Gumamit tayo ng Gilliland equation. Then, kung plug in lang siya dun sa equation, makakuha tayo ng value for kg. Ulit lang. Then, same for the wetted surface, makakuha tayo ng value. Pag pinlagin natin yung mga values na yun. And KL, makuha natin yung HG at HL. Itong, yung expression na yung for HG, yung sinasabi ko na in terms of mass transfer coefficients. Medyo mahirap na siya. So, factors affecting HETP. Generally, packing efficiency increases when the following occur. Packing surface area per unit volume increases. Efficiency increases as the particle size increases or as the channel size narrows. And then the packing surface is better distributed around the random packing. Tapos ito pa yung ibang mga naka-factor, yung L over D or L over G ratio, naka-affecting siya. And then the distribution of the liquid and vapor, and then other factors like the lambda pressure and other physical properties. And then to predict HETP, according to Perry-Lerner ways, pwede ko gumamit ng mass transfer models, rules of thumb, or data interpolation. Pero medyo tedious na itong mga thoughts na ito, so hindi natin siya. Please, try ka lang na, what does HETP stand for? May makakasagot ka? Okay, HETP stands for height equivalent to the theoretical field. Okay, next.
Ayan, so that we wetted wall column. So, ayun. Or, it's known as falling film column. So, parang ano, di ba sabi nga ni Earl kanina, lab scale experiments must be carried out before applying to full-scale operation. Kasi nga medyo mangyari. So, yun. Usually itong wetted wall column, ginagamit sa lab. Sa pag nag-YouTube kayo, may makikita kayong lab classes from other countries na gumagamit. Okay. So, para saan ba yan? Ano lang, nagde-define siya ng mass transfer para dun sa pag-solve nung yung parang kay Erwin kanina. Kasi ang mahalaga lang naman sa absorption ay yung mass transfer coefficient. So, yun. Using the wetted wall columns, lab scale, in a lab scale, makakompute yung mass transfer coefficient. Yes. Tapos, ayan. Ito yung equation for wetted wall columns. So, ito nga yung band dyan, yung ChE. Ito yung kailangan mo.
Malawag yung ano niya.
Yung following, yung mga susunod na formula. Bali, yung pinakita kong formula kanina, yun yung general. Ito yung general formula na ginagamit for the wetted wall column. Tapos, for certain conditions, may mga na-formulate din yung ibang scientists sa ibang equation. Ayan. So, mass transfer in liquid phase in wetted wall columns is highly dependent on surface conditions. So, kasi dun sa wetted wall column, yung column ay parang may film ng liquid dun sa column. At yung nag-transfer. So, yun nga, yun ibang type. Pag malaki yung surface mo, ito yung gagamitin mong value. Ayan, makikita nyo naman sa very last yan. Tapos, ayun yung mga
figure
ginagamit na Ayan, tapos, yung Reynolds number, ito, yung Reynolds number below 2,200 ay parang walang effect sa case coefficient. So, yung mga equations nila, nag-a-apply lang siya sa Reynolds number about 2,200. Yes. So, generally, ganun.
oh,
Ayan. Ano yung other term for wetted wall column?
falling film.
Yeah. Tapos, application.
Applications, nas na lang ito. Gas absorption is generally applied where hazardous, corrosive, or body-smelling components in air or gas exhaust streams are to be removed or neutralized. They are also used for removing dust particles from these exhaust streams. Yan, sabi dyan. Isang example na exhaust gas scrubbing can be necessary when using solvents with combustion processes and when using grease or hazardous gases. Pwede rin siya for acid gas removal, for removal of acid and toxic gases. Ayan yung example niya sa NGTech makita. Tapos, last na lang ay para sa improvement of air quality. Removal of air impurities such as SOx gas, SOx gases.
Yay!
So, yun. Thank you sa pakikinig. Sana may natutunan kayo. Thank you.
Sige, sige, pagpalakpak.
It all began at the show one weekend. I was a friend of your cousin. Said, hey, how you've been? And checker shirt on and my Reebok shoes on. Let's watch something random turn into something awesome, and I smile